Okay, before we get into today's information, I feel like we need to review the four types of patterns. I think a lot of you might have skimmed through the material last week. Maybe you thought that it was going to be an easy week or whatever, even though I kind of warned you. And I think it cost you a great deal of quiz points. And as a result, I think there are a lot of low grades and computer grades that aren't in. So it looks like you got a lot of work to do to get caught up. What I'm going to do is go over it one more time, but the rest is up to you. You have to learn how to find time to get help, whether it's before or after school. I'm here all the time, not for personal tutoring. For personal tutoring, you have to be in the morning, but I mean, there's plenty of spots for you to get extra help and extra things done. So other than that, we are going to keep moving through the chapters. I told you that we have to get through 12 chapters before the end of the year. I also said we have to do one chapter test every 3 weeks, so there is not a stopping point to where I can actually do this stuff. So anyway, remember there were four different patterns. You had one where there was a common x or just a regular x. You had one where there was an x squared, one where there was an x to the third, and one where the x was in the exponent. And the way that we determined these basic three, which was the easy part, which was to check the common difference and see if there was a common difference on the first part, then you had this type. If it was the second check, then it was this part. If it was the third check, we had this part. I had a lot of people who weren't even close on the variable itself, which means that you obviously did not practice. You did not really take the information seriously, and that's not good. But anyway, these patterns are determined again by finding the common difference. Afterwards, it takes practice to adjust the pattern, and every number that you're doing is adjusting the pattern to fit the current table. I'll walk through four patterns before moving to the new work. Just be sure to think and actually try to apply what I'm doing. This is not a class where you can just watch and say, okay, I get it, and I'm going to go work through the quiz stuff. You have to actually try to get it. Math is not that easy. I wish it was, but it's not. Also, you might want to consider retaking the quiz if there's something that I do here that helps you understand what you did wrong on the quiz Friday. That way you can get your grade kind of back to where it should be. I have to say I'm slightly disappointed, if not actually slightly, I'm almost very disappointed in the fact that there are so many low grades right now, because I'm working as hard as I can to get us the information. It's up to you to work to make sure you can apply it. Anyway, four patterns. What we have to do is again apply the common difference. What we do is we look here and we see that this is adding 3, because remember the x's are going up 1, which is typically what they're going to do when they want you to get a pattern, but that's going up 3. This is going up 12. This is going up 64 minus 16 by 48. This one here is going up 9, and this is going up 30 something, 36. And if you look at it, this really is a messy pattern. First off, the differences between these are so broad. I don't think these two are going to meet anytime soon, and like I said, even if I gave you extra numbers, I don't think it would meet. So this is where you check to see, you say to yourself, yes, I could check for 3 checks, but I would rather see if there's a common multiplication going on. So ask yourself, is there something I can do to get from 1 to 4 using multiplication? And I know I can multiply by 4. Is there something I can get from 4 to 16 using multiplication? And I know I can multiply by 4. Is there something I can do from 16 to 64? Let's see. 16 times 4 is 64. And so the pattern here is that you are continuously multiplying by 4. This represents the pattern where you're supposed to put 4 as a power, or as a base, with x as your power. And again, the way you check this, which I don't even think a lot of you are using your calculators during the presentations, but hey, I can't help that, is to type it in and check. 4 caret 0 gives me 1. 4 caret 1 gives me 4. Good. 4 caret 2 gives me 16. 4 caret 3 gives me 64. So this has to be the pattern because my calculator even verifies it. There comes a certain level of pride where with the calculator, the powerful calculators that I'm giving you, there's no reason to put a wrong answer because the calculator told you you're wrong before you even hand it in. And especially if you're finishing early, it just means that you're not fighting as hard as you should. But anyway, 0, 0, 1, 4, 2, 32, 3, 36. Again, the x's are going by 1, which is great. Let's check the common differences. 0 to 4 is adding 4. 4 to 32 is adding 28. 3 to 36 is adding what? That can't be the case. Hold on. Look at my patterns real quick. That should not be a 32. That should be 16. And so anyway, from 4 to 16 is 8. I'm sorry, 12. So plus 12 there, and 16 to 36 is plus 20. And then when you look at this, you have plus 8 here, and you have plus 8 there, which of course means that it's not a first level change, it is a second level change. Sorry for the mistake, but again, plus 4 there, plus 12 there, plus 20 right there. Checking that out is plus 8 plus 8. Once you find a match and you recognize that your match is on the second level, now you check your squares. And again, you take your calculator and you type in 1 to the second power. Actually, it goes 0 first, so 0 to the second power, of course, should be 0. So put down the numbers first, 0. 1 to the second power should be 1. 2 to the second power is 4. 3 to the second power is 9. And that's as far as we need to go. And then what you do is you list the numbers that are actually in the table, and then we have to analyze. We have to think at that point. So then we have 0 here, 4 here, 16 here, 36 here. And so now you look and try to figure out, and again, you have to think. I cannot make this easy for you. This is not going to be easy to do. You have to think. Ask yourself, am I adding or subtracting first to get these numbers? And I don't think you could be adding or subtracting because 0 is staying at 0. So I think adding's out. Now look at multiplication. Of course you can ignore the 0 because that's a crazy number, but what do I multiply 1 by to get to 4? I think that's times 4. What do I multiply 4 by to get 16? I think that's times 4. 9 to get to 36, I think that's times 4. So my adjustment number is to multiply by 4. And so all you have to do is take the x squared, recognize your adjustment, which is to multiply by 4, and simply put a y equals in front of it. And that is your pattern. And again, the beauty of it is I would not turn this in, especially if I have a decent amount of pride in my grade. I would not turn this in until I checked it out. So 4 times 0 squared. We practice typing these things into the calculator. That gives me 0. 4 times 1 squared gives me the 4. So 4 times 2 squared. 16. 4 times 3 squared. It's 36. So now when I hand it in, I know I'm right. I don't have to act surprised that I'm wrong or anything like that. Again, as long as I'm giving you the calculator, you should be using it to kind of check your answers. That comes with growing up and getting more responsibility. Anyway, C. Again, your x's are going up by 1. So let's check the common difference. This is not going up, so I want to make sure I say that this is going down by 5. Number sense says that I think this is also down by 5. And I think this is also down by 5. And so because this is a common difference on the first, it means that I have a x. Not only that, remember that whenever your first number matches, this is your rate of change. So what I actually have is a negative 5x. This is the easy one to do because once you see that it's a common difference, you simply put whatever the common difference is next to x, and then we adjust it. So now we have to take and plug only one number in. So it's the good news about this. We take one number in, we plug it in. Negative 5 times 1 is negative 5. The question is, how do we get from negative 5 to 6? Because that's what we actually should have. And so how do you turn a negative 5 into 6? If it's getting bigger, we obviously have to add something. And so now it's either number sense or calculator sense or whatever, but the easiest way to find the difference between two numbers is to subtract. So 6 minus negative 5 gives me 11, which means that I am actually adding 11. That is my adjustment number, and all I have to do now is put a y equals in front of it. And again, if I don't check it, then it's my fault. Negative 5 times 1 close plus 11 equals 6. That's good. Negative 5 times 2 plus 11 equals 1. That's good. Negative 5 times 3 plus 11 equals negative 4. Negative 5 times 4 plus 11 equals negative 9. Now I know I'm right. Now I know I can hand it in, and I can be confident in the result. D, last one, common, again, x's are going up by 1, which is what we gotta check first. This is going up 3. This is going up 5. This is going up 7. Yeah. Then you're going here. This is going up 2. This is going up 2. We didn't get to any third power things, but either way, you are on the second check, which means that we are talking about a x squared pattern. And again, whenever you do that, even if this was an x to the third on the third check, you simply take it and you say, okay, here's the x squared pattern. Let's remember all of our squares, starting with this. 1 squared would be 1. 2 squared would be 4. 3 squared would be 9. 4 squared would be 16. Then you list the numbers that you actually have, which is -2, 1, 6, and 13. And again, you think now. There is no shortcut. There is no button you can press. You have to think, and you have to ask yourself, am I adding or subtracting? And I would always check addition or subtraction first, because it's usually the obvious choice. How do you add or subtract to 1 to get to -2? If you don't know that, find a number that works better. How do you add or subtract 4 to get to 1? To me, you would subtract 3. What about 9 to 6? I think you would subtract 3. 16 to 13, I think you would subtract 3. And I think it also works right here, which means that my adjustment number is that we are subtracting 3 from our original, whatever this table would give, to get our part. And so that you put the adjustment on there. You put equals y in front of it. But not only that, if I am a student who has pride in what I'm trying to do in terms of the class, I type it in and I check. I do 1 squared minus 3, and I see that I get -2. I do 2 squared. Actually, there's a squared button. Minus 3, and I get, 1. I do 3 squared minus 3, and I see that I get 6. I do 4 squared minus 3, and I get 13. And again, I can hand this thing in now, knowing that I got it right. Please don't let that happen again. I mean, you're putting yourself in a bad position when you're allowing yourself to have a bad week from either laziness or anything like that. So make sure you fix that. Today, though, we're going to look at creating tables for values of functions and graphing them. We'll discuss what it means to be continuous or discrete. We'll also consider a way to identify independent variable in an equation. You will be asked to graph in this section. Although you have not been formally trained for the tricks and shortcuts that you will know soon. I think you'll learn that next chapter. I'm not sure. The first thing that must be learned in math, which is what I'm kind of telling you, is that sometimes you just have to fight for the correct answer with what you know how to do. In the situation I'm talking about with the quiz, you have one of these in front of you. So you can check your answer by fighting, by simply typing in numbers and seeing if it works, and if it doesn't work, make an adjustment. You won't always get the right answer first, and until you learn how to fight for the answer, you're not going to get as far as you want to get. Look at the following examples. You might want to write them down because these are your actual notes. But what happens whenever you want to graph is that you typically want to make a table of values. And again, this goes into your plugging in, and the table of values, the generic table of values, should usually go -2, -1, 0, 1, and 2. And so the best thing to do is to take those numbers and plug them in. Again, you have a calculator, so it's not that bad. If you didn't, you actually know the order of operations, so it shouldn't be that bad anyway. But plug in your -2, so 2 times -2 plus 3, which gives me -1. 2 times -1 plus 3, which gives me 1. 2 times 0 plus 3, I think I can do it from here. 2 times 0 is 0 plus 3 makes 3. 2 times 1 is 2 plus 3 makes 5. 2 times 2 is 4 plus 3 makes 7. And then what you do is you simply graph them. So -2, 1, if you remember x being -2, this is my x-axis here, means go back 2 first. And then -1 means go back 2 and down 1 and put a dot. And then -1, 1 means go back 1 and up 1. 0, 3 means don't go back at all but go up 3. 1, 5 means go forward 1 and up 5. And of course 7 is not on the chart, but you can see here that we definitely have a linear pattern. And so what we would do if you're on paper is take a straight edge, which we'll get to at some point, and draw your line that goes across that region, which of course makes it linear. Other than that, that's it. Oh, independent variable. The way you identify the independent variable in an equation is you say which one is the easiest to plug in for, and notice how easy it was to plug in for x. The independent variable is usually the one that's with all the numbers. The dependent variable is over here because my value of y depends on what I plug in for x. I like plugging in for this, which means that this is independent. I don't like plugging in for that because if I plug in for y, I have to move 3 divided by 2 and figure out what x is. So the independent variable is usually the one that you plug in for easily. The dependent variable is usually the one that you get the answer because it depends what I put in for here to get over there. Graph y equals negative 3x. Again, a generic table of values. 5 points, negative 2, negative 1, 0, 1, 2. Again, I'm pretty sure some of us are going to do it on Math XL. Others of us won't. Then you'll ask me questions. But as I said on the quiz, and it always tells me the truth, I will know who did right and who did wrong. Negative 2, 3 times negative, or sorry, negative 3 times negative 2, I know to be a positive 6. Negative 3 times negative 1, I know to be 3. Times 0 should be 0. Times 1 should be negative 3. Times 2 should be negative 6. Now you plot it. Negative 2, 6 means go back 2 and up 6, which is here. Negative 1, 3 means go back 1 up 3. 0, 0 means don't move at all. 1, negative 3 means go over 1, down 3. 2, negative 6 means over 2, down 6. We can obviously see that this is a linear function, and so we take our straight edge and we graph that function. Now when you do these graphs on your computers, if you don't know how, just let me know and I can discuss it with you. It's not that bad. Typically what you'll do is there's a button that says to open up the graph, and then you just place a couple of points, because really for any line, if you think about it, you only need 2 points. But you should work on making this table because this is what's going to get you credit on the quiz this week. And so yes, you can take your shortcuts on the Math XL like some of you do, but it's going to kill you on the quiz because if you don't have this full table for me, I'm not going to give you credit. So keep that in mind. C. The problem with C is the fraction, and it's the same thing that we've had the whole time, which is we don't like fractions. We definitely don't like fractions. So if I were you, I would pay attention to the advice that I'm about to give you, because there is still a way to get a decent table of values. First off, anything times 0 is 0, so multiplying a 0 in here definitely will help. But I would not just pick random numbers outside of that because of this denominator. But what we've learned is that if we multiply, or if we put a 3, if we multiply this by 3, then obviously the 3's would cancel. So I would count a 3 here. And then if I'm going from 0 to 3, I think another 3 should do it, because remember that 6 is a number that 3 agrees with. And so if I would do 0, 3, and 6, I would also do negative 3 and negative 6. And then we should see nice numbers that we can plot. Now, could we do negative 2 to 2? Yes, but then you'd have decimal numbers that you'd have to approximate, and I think it's much better to have nice numbers over here in y. Again, the reason why I chose 3 is because of that. 0 was nice because, again, 2/3 times 0. Anything times 0 is 0, and so 0 is typically the easiest choice to use. But in terms of my first step, 1 doesn't do it, because if I'd plugged in a 1, 2/3 times 1 plus 2, and I'd have to plot 2.666667, and I don't really want to do that if I don't have to. So again, the 3 is chosen because of the bottom number, and once I know that I'm going from 0 to 3, kind of like your common difference, add 3, subtract 3, subtract 3. But going back to this, negative 2/3, make sure you put your fraction in parentheses, times negative 6, I'll just put that in parentheses, plus 2 gives me negative 2. Again, you might have to work on your calculator programming too, but again, that's all part of becoming a mathematician at a higher level student here. So 2/3 times negative 3 plus 2 is 0. And again, you might want to type this stuff in. If you're not, this is on you. 2/3 times negative 2, I'm sorry, it's not 2, it's 0. Talking. 2/3 times 0 plus 2 is 2. 2/3 times 3, 3 plus 2 is 4, and 2/3 times 6 plus 2 is 6. And so now you plot all these. Negative 6, negative 2 means go back 6 and down 2. Negative 3, 0 means go back 3 and do not go up or down at all. 0, 2 means don't go back up left and right, but do go up 2. 3, 4 means go over 3 and up 4. And then 6, 6 means go over 6, up 6. And again, you can see that you have a linear pattern here. So you would take a straight edge and connect those with a line across the region, and that would be your graph. So that is what your graphing is. Again, pick your 5 points. I would say definitely for Math XL, make sure you work on doing the table. Again, a lot of you are trying to be slick and work through Math XL as if you're going to get away with it, but hopefully, again, stop making foolish decisions, because it's going to hurt you at some point and the information is only getting tougher. You'll also be asked to identify whether a graph is continuous or discrete. One way to consider this is to imagine 2 water faucets. If you say that the first faucet flows continuously, it means that water is continuously going through. There is no break in the flow of water. That is what continuous is. If you've ever seen faucets on the movie, or the kind of joke faucets to where when they turn it on, it kind of spits out water and then doesn't come out and comes out again, it's kind of like water off, on, off. That would be discrete. And so let's look at some situations here and just think, because again, in order to do this, you have to kind of think through it, and it's kind of an understanding thing more than anything else. But if you see a continuous graph looks kind of like this. It'll just flow and go wherever it's going to go. A discrete graph just has a bunch of dots, because you notice the dots are all over the place. Here is where the water is flowing continuously. Here's where the water is coming out in spots, and it's just all over the place. So that's continuous, that's discrete. That's really how the word works. And like I said, you understand the 2 words, I think, so make sure you apply that understanding of the words whenever you answer the questions. It talks about the height of juice in a 20-ounce bottle. Depends on how much juice that you drink. Does this represent a continuous or discrete situation? You'll see this on the test. It's not a hard question as long as you ask yourself this question: is it possible for me to drink 1.7 ounces? I think so. Is it possible to drink 1.77 ounces? I think so. Now, I may not want to measure that, but I think that I can drink any amount just by sipping or pouring or spilling or whatever it is. And because I can have weird numbers like this, that means that this is more than likely continuous. Again, this graph, if you're talking about the graph, for those of you who didn't know how to do the graph, you have the height and you have the ounces that you drink. It's a 20-ounce bottle. If you drank no ounces, the height should be high, and as you continue to drink the ounces, it should drop and go here. And so again, that would be what your graph would look like. And notice that it flows through, because there is a definite amount for each part. Another one would say something like the weight of a tractor trailer depends on the number of cars it is carrying. Again, is this continuous or discrete? Think about this. Is it possible for them to carry 1.7 cars, 1.77 cars, 1.777 cars? Because if these numbers exist as possible, then it's probably continuous. I don't think you would carry 1.7 cars. You would carry 1 car, or 2 cars, or 3 cars, or 4 cars, which means that it doesn't flow in between 1 and 2, in between 2 and 3. It spits out answers in between 1, 2, 3, and 4. And this graph would look like this. If this is weight and this is cars, then at 0 cars you would have 0, and then at 1 car you would have a certain amount, and then at 2 cars you would have a certain amount, and at 3 cars you would have a certain amount. And as you can see, the values depend on jumping across the x-axis. It doesn't flow continuously to where you can have any amount of ounces. It says 0 cars, 1 car, 2 cars, 3 cars, 4 cars, and so on, because there is no such thing really as 1.77 cars. And even if there was, you wouldn't have a 0.777 and anything else that 1.89345. If it was continuous, then you would have somewhere in there, and it just doesn't work like that. So again, if you can't do weird numbers like this in the situation, then obviously it's not continuous. It's got to be discrete. Again, over here, in terms of amount that you could pour out, in all honesty, you could pour out any amount. You really don't know. But this, there is no way that you can get any just any amount of a car in there. Another one says cost for an order of pizza depends on how many pizzas are ordered. They want to know if it's continuous or discrete. Again, think about it. Can I order 1.7 pizzas, 1.77 pizzas, 1.777 pizzas, 1.2, 3, 4, 5, 6, 7, 8 pizzas? I don't think so, which means that this would be discrete because you have to order 1 or 2 or 3 or 4 or 5 pizzas, which again means that if you graph that, this would be the cost and this would be the number of pizzas. And so with 0 pizzas, your cost should be 0. With 1 pizza, your cost should be a certain amount. With 2 pizzas, it should go up. And again, you notice that your graph has a pattern to where it just kind of spits out numbers in random parts. And then the last question we're going to look at. The area of an isosceles triangle depends on the length of one of its legs, continuous or discrete. Ask me this, can one of the legs be 1.7 units? I think so. Can it be 1.77 units? I think so. What about 1.777 units? I think so. What about something weird like 2.78721342? I think so. And because all of these can be lengths of its legs, now do we want to work out that problem? No. But because all of these could be in a math problem for us, it means that it is continuous, which means that, again, if you're looking at it, you're talking about the area being here and the length of the legs. Again, no length would be a low area, but as the length goes up, the area should go up. And so you notice that we don't know how long the length is, but as the length increases, the area should also increase. And you notice that you have a continuous flow of information. And so there you go. Use the rest of the time to work. I don't know how much time you have left because I had to do a longer video because, again, I take this stuff personal. I graded the quizzes. They were not nearly as good as they should have been. I always open the door for mistakes that are understandable, but some of you missed almost every question on the quiz, which is just not great, especially when you have the capability of watching the videos and doing what you need to do to be where you need to be. But I've taken the barrier off the B assignment, so then you no longer have to get 100% on A. You're fine. You no longer have to get 100% on A to move to B. I've also opened it up to 2 attempts, but I am afraid that some of you are still going to make foolish decisions. As I have here, my opinion of that is one that continually leads you to a bad place, but you keep choosing to make it. Please make sure you change your habits soon. The information is not going to get easier. It is not going to slow down. But I'm not saying this to say you cannot make it. It means it's time to kick in and fight harder. So again, use the rest of this time to work. Make sure you find time to ask questions. Make sure you find time to fix your quiz if you can. It's time to get your grades back where they belong. Good luck.